So why do we want to put it in AWS? And we really want the scalability. We hit a point in our current data center where we couldn't really handle the load anymore. We had to extend with new hardware. We weren't ready for the move yet, but we still needed to extend with hardware. And it took us 3 months to get new hardware. From the point that we were ready to say, this is what we want to order, this is how many we want, which types we want, and the contracts were signed, it still took 3 months in order for us to get new data nodes up. And that's way too long time. We can't really do that. We need to be able to move faster. And we also want to be able to scale down, because if the business plan changes and we say we don't need to save data for as long as we do, then we won't need as many nodes anymore. We can scale down as well. We also want the flexibility. So we currently run Elasticsearch 1.7. That's a really old version. And the reason why we can't upgrade is because we want to run very many more nodes during the time we upgrade. And that means that we would have to buy a lot of hardware that we use for about 2 months top, and then we throw it away. So we're going to put all that new hardware we just bought. In AWS, we don't have to care about that, because we just release it and then we don't have that problem anymore. So a really, really, really short introduction to infrastructure as code. I like to think of it as a recipe. You start with a really nice recipe with ingredients, you cook, and then you get a nice pasta dish. In the same way, you start up with a configuration. You have the ingredients, that is the resources that you want to use, you define them, you build it, and then you get a nice thing running in EC2, for instance. So this is a configuration for a module that is named Bastion. And when run, it will spin up a new instance in EC2 that is named PSS Bastion, and some numbers. That is really simple, and it was super short, right? So while working on this, we have made a few choices. And I'm not trying to tell you that these are right choices in any way. I'm not telling you, go home, do what we did. I'm not telling you to say, oh, but I heard this girl, she talked about this, and they made these choices, that must be really good choices. We just actually did something. And we picked Amazon Web Services as a cloud platform, and we didn't really look into the others, to be honest. I know there's Google Cloud Platform, I know there's Microsoft Azure, but we just picked Amazon Web Services. It has the scalability that we need. It has a lot of tools that you can use and integrations, and there's many users. If you get stuck on a problem and you Google it, someone else has probably had the same problem, and hopefully also a solution. So we can do whatever we needed, so we just took it. And we also chose Terraform. Terraform is an infrastructure as code tool. It can run towards AWS. And when we started out with it, it was really new. It was the new cool tool. And I think, to be honest, that was the biggest reason we chose it. I also made up a few reasons, which is that the development was really fast. That meant if you had a problem, no one had solved it at the time you Googled it, but if you wait a week, the new release was out and you could upgrade and everything worked, more or less. And that's also one of the problems, because it's not backward compatible. So that means if someone in your team upgraded to the last version of Terraform, built with Terraform, then you can do anything until you upgraded, because it now supported a different version. I also think that Terraform is more user-friendly than CloudFormation. CloudFormation is AWS' own tool for doing infrastructure as code. And at the time I used it, it was kind of hard to use. It wasn't really that good, and I think Terraform is better. It's also possible to use Terraform for multiple platforms. It supports most of the large, big cloud platforms, such as I mentioned before, Google Cloud Platform and Microsoft Azure, OpenStack, and Amazon Web Services. So it's possible to collect all your infrastructure as code in one place. And we use Puppet. We use Puppet mainly for installing software, distributing upgrades, and fix user access, etc. And we have no good reason for using it other than we always did. So we know how to use it and we can reuse some of it. So our setup. I'm going to try to explain what we have done and how we done it. And if it's not clear, we can talk more about it later. So the goal has been to, we have our Elasticsearch cluster and we have a few services that communicate with it. And the goal is to have those services not knowing it has moved. The way we did that was that we created a new virtual private cloud, a VPC, in Amazon. And we created a private gateway back. And that means that we just push the data back and forth. And the latency is really not a problem. We have benchmarked it, and it's not notable at all. So it works really well in that way. We also have in AWS you have availability zones, and we're distributing our data nodes across the availability zones in order to have better security in case an availability zone goes down. For our infrastructure as code, we have the set up so that we have different branches, and we were using Git. So we have the branch dev, that is the development and experiment branch. And in that one, we do all the development, all commits goes to that one. And we can try new things out, we can fix things and experiment a bit. And when we reach a stable state that we feel like we wish this was staging, then we do a Git rebase dev in staging, and we run Terraform. In that way, we never commit anything straight to the staging branch, because that would be insecure and actually kind of screw up the Git history. We don't like that. And in the same way we could use, in the theoretical future with the production environment, we will have a production branch that always rebases on the staging branch. Each of these branches also have a specific variables file, that the .vars. And this means that we can have different configuration for each branch. So in the development environment, we will not run as many data nodes as we do in the staging cluster. And we can change names and etc. So the things that will vary, but still not be that big changes will be in the variables files that we can change between environments. This is code. I tried really hard to find a good piece of code that I could show you live in IntelliJ. But to be honest, the setup is really large, and it takes a while to get used to the format. So I just wanted to pick out this one because this is the virtual private cloud module that I talked about earlier, the big box, the gray box. And as you can see in the small green box, there is the var.vpc name. And that's typical something that we set in the variables file. And that's because in Amazon you can't have the same VPC names onto VPCs. They have to be unique. We really need to put this in the variables file. And also you can see by the comment over here, this is actually some hacking we had to do. I guess we Googled a lot in order to find that out. That to allow traffic between. Each availability zone gets their own security group, and you have to tell them that you're allowed to talk to the next availability zone in order to communicate between those. This is our master node in Elasticsearch. We usually run 3 master nodes and then X number of data nodes. And you can especially see the count and instance type. And this allows us to change how many master nodes we run, and also what EC2 instance type we run. And we might want different ones because these are there's a cost per hour attached to these instance types. And if we don't need that much power in our development environment, then let's not spend all those money in vain. Let's be wise. And this is a very small part of the variables file. So we have the VPC name, as I pointed out earlier. It's PSS for this example. This is our platform search staging, is what PSS stands for. And platform search, that's where I work. Staging, you understand. And we also have the master node, and we can see that we're running instance type R4 2x large, and that we have 3 of them. And you can also see that we have the this ES storage hot is our data nodes. We started off thinking that we will have 2 different types of data nodes. We will have hot, we will have cold. We will only have hot, so now everyone is hot. And the instance type we run is the new fancy i3 2x large. And we have a problem with that because Amazon is a bit slow distributing those to all the availability zones. So currently we can't get more than like 20 of these types in availability zone C. So we only run in A and B so far. And we run 88 of those. Actually, we run 92 since like Monday or something. But this is from the weekend, so out of date already. So we have a lot of nice configuration. The recipe, the defined vegetables. Now we're going to build it. And building it we can do in different ways. We have set up on your left, there is the AWS code pipeline. It's automatically built when we push code to the staging branch. It will check out. It will see that everything works. You don't have any compilation failures. Then it will run plan. Plan is the first step in Terraform. This is where you get to know what is going to change. How does this match to what I already run? And if that is what you expect, then you have to manually push the review button and say, I agree, this is what I want to change. Let's apply. Apply is the step where it actually spins up new instances, tears down the ones you want to destroy, etc. And you probably understand why we really want this manual intervention before just running it, especially when we have we counted on it, and I think we will end up around 300 data nodes in production as well. And we don't want to accidentally tear down those. And on the right, there's the command line. You can also run it by command line, which is basically what happens in code pipeline. It's good if you have made a few changes. You have checked out your code, you have tried it out, and you want to be sure what are the changes I'm going to do. So you say that I'm in the environment, PSD, because I didn't want to do this towards the staging environment. And you say that I want to run Terraform, that's the scripts file, and I want to plan. And then it does a lot of calculations. There's so much output here, I had to cut it out. And then it says, this plan will create no instance. It will change 2, and it will destroy 1. Since I had made no changes, I thought this is strange, so I just backed out at that time. But this is the time when you think, is this really what I wanted to do? Is this the changes I wanted? So, this is what it looked like. The variables files we had earlier, we said we wanted 3 master nodes. We said we want to run them in the VPC name PSS. We want R4 2x large. And it actually also said, but I didn't tell you, that it should be distributed over the availability zones A, B, C. And this is a sample, just the 5 first data nodes. And as you can see, we only run them in A and B, every other one, because there's not enough nodes. after this step, this is what happens when you have run Terraform the first time. It will start up all the instances that you want. And then we have set it up so Puppet will run automatically on all instances as soon as they become available. And Puppet will install Elasticsearch, and it will also start Elasticsearch as soon as it's installed. And when it starts, it has all the configuration it needs in order to join the cluster as soon as the master nodes are up. So, though it takes a while, I really want to do a live demo, but to be honest, it takes way too long in order to run both Terraform and get the instances up. But this is what it could look like when you get it up, and you can SSH to the master node, and you can cut out the health for the cluster. So also as of last week, we actually run Elasticsearch Elasticsearch staging in Amazon Web Services. And we actually, as of yesterday, we moved it back. And now we're going to move it back and forth, because every time we move it, we realize, oh, this is not as we wanted it, or this went a bit wrong, or we almost lost data here, and we don't want that to happen when we move production. So we're going to continue moving it a bit and learn all we can do about infrastructure as code and Amazon Web Services. So the process of doing this, as you probably understand, is that we have also found out a lot of challenges, and mainly we have overcome most of them. Some is not critical yet, but, well, at least, I hope. One of the challenges is really about losing instances. And it could be due to many different reasons, but the most common one for us so far has been Amazon sending us an email telling us that instance XXX is going to go down, and it's going to be retired within a month. Usually by the time we get that email, that instance is already dead to the cluster. It's gone. We lost that node. And it could also be like hardware failures. Sometimes we notice a problem before Amazon does. And also, as I mentioned, the human factor is a really big one. And the biggest risk feels like us doing a change, not really checking it, and then just pushing the apply button in Terraform and tearing down all the data nodes we have. Another challenge is to not lose data. And I think this is the scariest one, because I know how long it takes to reload the data into the cluster. And that would mean we are down for weeks if we lose all our cluster. And we have to do a full cluster restore from snapshots. And it's a huge risk of getting inconsistent data. So it's super scary. We don't really have a good solution yet, other than just trying to spread the data out, having many replicas. But worst case, if we lose one instance in each availability zone, we still risk losing data. And I think that's something that we will work more on, but it's also how secure can you get before it takes too much time. Another thing that has been a challenge is that when we started out, we had a few services written in Java, of course. We had Puppet, as I told you. We used to build our Java code in Jenkins. We actually had a few Ruby scripts for debugging. And that was about it. Now we add AWS, we add hardware knowledge, we add Python, we add Terraform, Bash, Travis, and a lot of things that I couldn't come up with when I wrote this slide. And the complexity has increased a lot, and as a team we need to get good at a lot more things than we were before. And that's a challenge as well. We have learned a lot since we started working on this, and we have a lot more to learn, I would say. The last challenge. Cost awareness. This is really not about being cheap. We spend a lot of money, trust me. But it's that we know that we spend money that has been a challenge, because before we started this work, we only had a limited hardware resources, and we knew the resources we had. If we wanted a new machine, we went asked someone, can we get a new machine? They said, well, yes, or they said, no, or I don't know. We didn't have to care. This really just has increased a lot. And it's about being aware of what does it cost if we run 300 i3 nodes, or what compared to if we run something else. And also, actually a lot about cleaning up your experiments. It's super easy to start instances in AWS. It's super hard to remember to shut them down when you're done. I don't understand how it can be so hard. I actually talked to a friend of mine who works a lot in AWS, and they had created a tool where they listed everything that was not tagged, all instances that was not tagged. And they just killed them. Unless you said, I actually own this machine, they just kill it in order to clean up their costs. And they saved a lot of money each month just doing it. So this is also a challenge, and it's new to us. So what does the future hold for us? You probably can guess. We're going to move Elasticsearch in production to AWS. And also we have a few more services that we hope will follow. And by that we also hope to be self-owning our stuff. Thank you all for listening.